Welcome to the Python lecture, everyone. In this lecture, I'm going to talk about set. Set is another collection after list and tuple I'm going to discuss. Again, so set is having so many different kind of use cases while doing a coding, programming, and while processing a data set. So let's try to understand set in a practical manner. Let's try to do our hands dirty a little bit, and then we'll try to solve a couple of problems with respect to a set. So let me start. I believe my screen is visible. So like I said, guys, set is another collection. Collection means a kind of a entity where I can hold a homogeneous or maybe a heterogeneous different kind of a data set at a time. This is what is called as collection. So set is another kind of a collection that you all will be able to find out. How to create a set? So here, to create a list, we were using a square bracket. To create a tuples, we were using a simple bracket, normal bracket, parenthesis. And to create a set, we are supposed to use a curly braces. Yeah, curly braces. Execute. Now here, if I'm going to use this curly braces, and then if I'm going to check what is a type, I already told you it's a curly braces, right? This is the statement which I have made. Now I'll check my statement, whether my statement is correct or whether my statement is incorrect. Okay. Now, I told you that curly braces can be used to create a set. This is what I said. Now, when I'm trying to check a type of this particular variable s, it is telling me it's a dictionary, right? It's telling me it's a dictionary. Now, I'll try to show you something different. So here, I'm going to create again s1. Again, I'll take a curly braces. Okay. Again, I'll take a curly braces. This time, I'll try to keep at least one element. At least at minimum one element I'll try to keep. Execute, and then I'll try to showcase this type check. So S11, and it's a set. So I told you to create a set, it's a curly braces that we are supposed to use. Even to create a dictionary, which will come right after this set chapter, right? We try to use a curly braces. But dictionary is completely different. I'll talk about it in very detail, believe me. And here, let's talk about a set. So even to create a dictionary, we use a curly braces. Even to create a set, we do use a curly braces. But there is a huge difference between set and dictionary. You all will be able to find out. Now, what is that different? So once we'll talk about a dictionary, obviously then we'll try to do a comparison. As of now, just try to focus on set. So if you are using a curly braces, and at minimum, if you have one single element inside that curly braces, then system will be able to identify it as a set. Otherwise, system will try to identify it as a dictionary. For now, this information I think is useful for all of you. Now, what is set, by the way? Yes. And is there any way by which we can try to create a set? Or maybe some different way, because with the help of curly braces, by keeping one minimum element inside that variable, yes, I'm able to create a set. I'm able to check a data type. It is telling me that it's a set. There is a function called as set. Now here, if I'm going to check a type, what is a type? Type, type of, what is a type of this one? So again, it is going to be set. Now, so these are the two way. So this is similar to a list, which is similar to a tuple. So even when I was trying to create a list, so I have done the same thing. A square bracket is one of the way. List function is another way. Same goes with the tuples. Simple parenthesis, one of the way. Tuple functions is another way. Here in case of a set, one element at minimum with a curly braces is one of the way. Other way is by using this particular function. So in this way, I can try to create a set. Now, why do we need a set when we already have a tuples and when we already have a list? So let me show you that as well. So here I'm going to create S2, curly braces, right? I'm going to keep 1, 2, 3, 4, 5, 6. Again, 1, 2, 3, 4, 4, 4, 4, 4, 4, and then 5, 5, 5, 5, 5, 4, 4, 3, 3. Okay, fine. So I'm trying to keep a multiple element, as you can see, inside this particular variable set. And most of the element which I'm trying to keep over here is a repetitive element, right? It's a repetitive element. So we have a 1 multiple times, we have 2 again multiple times, we have 4 multiple times, we have 3 multiple times, we have 5 multiple times. So there are so many elements which is available over here which exist multiple time. I can try to even keep some sort of a string over here. So SUDH and then SUDH So I'm going to keep my name multiple time over here, SUDH, and S capital UDH, SUDH. Okay. So I'm just trying to keep a multiple occurrences of all of these elements. Now, I have created a variable S2. If I'm going to print S2, if I'm going to show you S2, how S2 looks like, you will be amazed. You will be amazed to see that we had so many elements inside my set, inside this particular variable. But when I'm trying to print it, all of those elements has gone. Which elements has gone? The element which was having a multiple occurrences. So all of those element which was having a multiple occurrences inside my set, inside my variable, all of those elements have gone. So what is set, by the way? So set is a distinct collection of an element. Set always try to keep a unique element inside it. It will always try to discard automatically. It will not even ask you, right? Automatically it will try to discard each and everything which is a kind of a repetitive in nature inside a particular variable. But now you can raise a question that, okay, you are saying that it will try to keep only a distinct element. It will not try to keep a repetitive element. Yes, that's true. So why it is keeping this and this? Yes, why it is keeping this and this? So see guys, here I have written Sudhanshu, Sudhanshu, Sudhanshu. Okay, I have written Sudhanshu, Sudhanshu 3 times over here. Now, these two are same and I would say that this is different. Although number of characters are same, right? Type of character, kind of character are same, SUDH, SUDH, SUDH. But in this one, as you can observe, S is available in a capital letter. Python is a case sensitive language. It will always try to discard, or it will always try to treat, right? It will always try to discard the same one if it is inside the set. So yet, yes, it has discarded one and it's just trying to keep one of it. Now, why it is keeping this one? Because of this. Because my S is in capital. So this and this is not same according to Python. Like I said, Python is a case sensitive language. It is going to treat uppercase in a different way and lowercase in a different way. And because of that, it is not discarding it and still it is holding a unique element inside it. Okay, fine. Now, this is set. That's completely fine. Now, set always stores unordered collection of a data. Unordered means there is no order at all. As you can see, right? There is 34 before, then 4 and 5, then 55, then my name, all those things. So set always try to store unordered collection of a data. Sometime while working with the set, you will get a feeling. Again, mark my word. Sometime you will get a feeling that set is trying to remove a duplicate as well as it is trying to order my data. But believe me, my dear friend, it is not doing it. Set is a unordered collection of a unique data set. So set never try to hold an order of the data set. Now, if it is not holding an order, will I be able to access a data with the help of indexes? Let's try this out. So here we have S2. I can try to access a data with the help of indexes. Execute. This is the problem. Set object is not subscriptable, right? We were able to access a data in case of a string, in case of list, in case of tuple, but when it comes to a set, I'm not able to access a data. Why? Because it is not having any kind of a order, and if it is not having any kind of a order, it is not able to assign indexes to an individual element. So I'm not able to do a indexing operation. So I will not be able to do a slicing operation. Yes, you can try to convert this set into a list. Just call list list function, pass this variable. You will be able to do that, right? Because once it will become a list, right? Once it will become a list, then obviously those data set will be having a indexes. But in this format, you can't do it. Very simple. Okay. So with respect to a set, indexing and slicing operation is not possible. Yes. Keep that in mind. With list, with tuple, with a string, yes, it is possible. But with respect to a set, it is not possible. Means it is not possible. You can't do those indexing and slicing operation. Now, Let's suppose I'm going to create S3 and here, so I'll try to keep maybe a list. So here I'll try to keep a list, execute. Now I'm trying to store a list inside a set, unhashable type list. It is not able to store even a list. So list I will not be able to store inside a set. List inside list allowed, list inside tuple allowed, tuple inside list allowed, but list inside set not allowed. Now let me show you some other magics as well. So here I can try to store tuple. Last time I was trying to store list. This time I'll try to store tuple over here. Now this is allowed. So tuples are allowed inside a set, but lists are not allowed. Why? Because lists are basically a mutable entity. Tuples are immutable entity. You can't change something, so that you can try to store. Even string is immutable, right? String is also immutable. So we can try to store string inside a set. We are not able to store list inside a set because it is not able to hash it. Okay, set is not having that capabilities. Technically, list is a mutable entity. We can't store inside a set. Whatever immutable entities that we have, yes, I will be able to store inside a set. Simple. Now, there are so many functions. Let's suppose if I'm going to take S2. So there are so many functions which comes along with the set. Let's try to understand one by one all of those functions. If I'm going to call S2 dot, you will be able to find out these many functions, right? You will be able to find out add, clear, copy, differences, difference update, discard, intersection, intersection update, is joined, is disjoint, is subset, is upper set. There are so many functions which is available with respect to a set. These functions are not at all difficult. One by one, I'll try to talk about all of these functions. Okay, so let's get started with the inbuilt function with respect to a set. Now let's suppose if I have to find out that what is a total number of element inside a set, I can do that. So what will be the total element? Total distinct element, it is always going to give it to you. So what is the total number of distinct element? Total number of distinct element is basically 9. So I'm able to get the answer. Okay. Now the next function. Let's suppose we have a set. We have a set. We have set S2, as you can see. Then I can try to call add. Now what this add will do, so you can try to pass a data and then you can try to add inside a existing one. So here, if I'm going to pass 3 is already available, right? 3 is already available. Now if I'm going to add it, execute, it is not going to complain. It is never going to complain, but it's not like it will try to add 3. If 3 is already available, because before adding, it is going to check all the time that whether this element is already available or not. If that element is already available, it is not going to complain. It is not going to throw any kind of an error. But at the same point of a time, it is not even going to add that particular element inside my set, because the nature of set is very simple. It always try to maintain a distinct element inside it. Okay, so set is completely fine. Now, let's suppose if I'm writing S2, which is my set, and then I can try to write another function called as remove. Now, as function's name suggests, remove means remove the data. Very simple, right? So if I have to remove 3, execute. Now check S2, 3 is gone. Previously we had 3. Now 3 is gone from the set. So remove will always try to remove the data from the set. Now, let's suppose if I'm trying to perform a remove operation, I'm trying to perform the remove operation. I'm trying to remove 100. Execute. Now, we all know that 100 is not available. If 100 is not available, if some data set is not available, it is going to throw the error. You have to do exception handling to handle it in a runtime. So whenever you will write a production grade code, which we will discuss again in a coming future. So how to handle this kind of error with the help of exception handling. But yes, in case of set, if some elements are not available, it is going to complain that yes, there is no such key which is available inside me, which you're trying to remove. So I'm really very sorry, I can't remove it. Okay, so remove is fine. Then there is a function called as discard. Okay, there is a function called as discard. So let's try to talk about this discard function. So what discard does? So again, hover your mouse. remove an element from the set if it is a member, right? So unlike set remove, the discard method does not raise an exception. So here we have discussed just now removed, and remove is doing what? Remove is giving you a error if element is not available. Now discard is going to perform the exact same thing. Yes, exact same thing. But here if I'm going to write 300, I think 300 is not available inside my set S2. They are the only element which is available inside my set S2. 300 is not even available. Now execute. No error, right? No error. So maybe I can try to use remove. If there is no such element, it will give me an error. If I'm using discard, it will not try to remove if there is no element. There is no case of removing it, right? If there is no element at all. But at the same point of a time, it is not giving me an error. If that element is available, let's suppose I'll try to remove 34. Okay. So S2 dot discard. And here, if I'm going to pass 34, now if I'll go and check what is S2, 34 is gone. 34 is gone. So difference between discard and remove is remove will give you an error if there is no such element which you are trying to remove, but discard will not give you error if there is no such element. That's the only difference between set remove and set discard. You all will be able to find out. Now we have S2, let's suppose. I'll try to write S2.pop pop. Okay. I believe we have already encountered this pop kind of a function in case of list, which will try to pop up the element. So if I'm writing a pop without any indexes, it will try to pop up the element from a very last indexes. This is what we have discussed in case of a list. And if we are writing an indexes, it will try to pop up the element from a particular indexes. But in case of set, there is no indexing concept, right? There is no such indexing concept which exists inside a set. So if I'm going to execute it, by default, it will try to remove. Just go ahead with this pop function. So pop, and it will try to remove any element, right? It will try to remove any element at any point of a time from a particular set, because there is no such indexing concept which exists inside a set. Now, let's suppose if I'm going to write S2 dot clear. So clear means wipe out all the data. Now, if I'm going to call set, there is no data. It is not deleting the variable. Yes, it is not deleting the S2 variable. It is just wiping out the entire set. It is just trying to clean out the entire set. This is what it is trying to perform in case of a set operation. Now, there is an operations called as union operation. Okay, there is an operation called as union operation. So here, let's suppose if I'm going to write 4, 5 and then dot. This is a set. Right, this is the set. I'm just trying to take it directly. So 4, 5. And if I'm going to call union, and if I'm going to write 5, 6, execute. So here in a form of set, I'm supposed to pass a data if it is a union. Okay. Now here, let's try to understand. So here, what union will do? So union will try to give you the union of two different element or two different collections, right? So here union simply means that we had 4, 5 and 5, 6. We have 4 elements. We are trying to do union of this with union of this one. So it will try to create one single set where all the elements will be available. All the elements will be available. So here final set is going to be 4, 5 and 5, 6, right? 5 is repeating itself even over here and even over here. So it will try to do what? It will try to give you the distinct set with inclusion of all the elements. This is what union does. Now, similarly, so we have basically a intersection. So union, yes, the entire element set, it is going to give it to you. Now, let's suppose I have a set. So not a square bracket. I have to take a curly bracket. 3, 4, 5, 6, 7. And then I'm going to write intersection. Okay, intersection. And here I'm going to write maybe 2, 3, 4, 5, 1, 2. So this function, this is a set. I have taken a set. I can try to store it inside some variable. I can take a variable name over here. Same thing I can do it even in this particular place. Yes. Now here, so if I'm trying to perform this intersection, this. Now let's try to execute. Let's see what happens. Now here, it is giving me invalid syntaxes. So I just have to wrap it up inside a function. So just try to keep it inside a function, and now it's completely fine. Intersection is basically a function. Execute now. Now here I'm able to get 3, 4, 5. Now why I'm able to get 3, 4, 5? Again, answer lies within this particular word. Let's suppose we have two circles, A and B. Now what will be the intersection? The common one, right? The common one is going to be the intersection. Now this is a same operation it is going to perform. So it is going to take this one and it is going to take this one. Whatever is common in these two, it is going to give you that as an outcome. So 3 is here, 3 is here, 4 is here, 4 is here, 5 is here, 5 is here, right? So it is giving me the outcome. This is what intersection does. So it is just going to give you the common element between two different kind of a set. Now let's move ahead. Let me remove this part. Now, so intersection is done. Now, let's try to take maybe differences. So here I can take a same set, instead of intersection, difference. Okay, execute. Again, just go after the word. What it is going to give you as a return. So whatever is a difference between this and this particular set, it is going to return you that particular part. Now, just go after this line. Return the difference of two or more set as a new set. All elements that are in this set but not on the others. What is the meaning of this? See, just go after this particular line. What is the meaning of this? You all will be able to understand. So this is actually my set. This is my actual set. And I'm trying to find out the difference with this one. Yes, I'm trying to find out the difference with this one. So 3, 4, 5 is common. So it's available here on my left hand side as well as on my right hand side. Now, what is a difference between this and this? So 6 and 7. Don't say that 1 and 2. Yes, 1 and 2 is a difference. I do agree with you, all of you, right? But it is not going to give you that as an outcome. It will always try to compare this one, which is the input one, with the new one that you are going to pass. And whatever is a difference that we have in the old one, which is on the left hand side, it is just going to give you that as a differences. Okay, fine. Now, same entity I'll try to take and I'll try to call difference update. Now, let's see what happens. So in case of a difference update, right? In case of a difference update, remove all the element of another set from this particular set. So remove all the element of another set from this particular set. What is the meaning of it? So what it is trying to perform internally. So it will always try to remove all the elements of another set from this particular set. Now, do we have any other element in this one, which is a part of this particular set? Let me show you that part by adding some of the data set. So here 1, 2, execute. Again, there is no differences that we are able to find out. Now, let's move ahead and let me show you with some different example. So what is a meaning of this difference update? So here, let me just try to create a set S with these two values 1, 2. Okay. And then I'm trying to call S dot difference update. Fine. And then here I'm going to pass maybe 2, 3. Fine. Now S difference update 2, 3. Now print S. What is a leftover? So here I have not stored this data into a variable. That's the reason. So it was not behaving in that way. So here that's the reason. So I have stored one data into a set. Now difference update. Now see, we are trying to do S, which was having 1 and 2. And then I'm trying to call difference update. Okay. Difference update 2 and 3. Now, whatever differences that we have, whatever different data that we have, it is removing it from this particular set. And then finally S is equals to 1 is something that I'm able to receive. This is what a difference update does. Now let's talk about another function. So intersection, I believe I have already discussed. Differences, I believe I have already discussed, right? Now let's talk about something called as update. So here, let's suppose we have a set 1 comma 2. Okay, similar kind of a set I'm going to take. Set s dot update if I'm going to call. I believe I have discussed update, or no, I have not discussed update. So let's talk about it. So set dot update, and let's suppose, right? Let's suppose here if I'm going to give 2 comma 3. Now what will happen in set? So it will try to update it with this one. So wherever we have a distinct element, or we already had 2, right? We already had 2, and we all know the property of set. It always try to keep the distinct element. So whatever new element it will be able to find out, it will just update it. So here is a final data that we are able to receive. Very simple, right? Here is a final data that we are able to receive. Now, there is something called as, let's suppose set s that we have, and there is something called as set dot intersection update. I believe we already talked about intersection. Yes, we already talked about intersection. Now let's talk about intersection update. So execute. Now if I'm going to print s, what is the meaning of it? So whatever intersection data we'll be having with this one and the new one, only that will be a part of final set. So here we had 2 and 3 and 2 and 3 common. We don't have 1 in this new one, right? So there is no intersection in between this one. Wherever we have an intersection, so it will try to update a variable only with those data inside a set. So intersection update is done. Now there is something called as difference update. Difference update, I think we have already discussed, right? There are so many functions. Yeah, difference update we have already discussed. So with the difference of the data, it will be able to update it. Now update is done, intersection update is done. Now let's talk about, let's suppose I have a s, and then I can try to find out s dot is. So is subset. There is something called as is subset. Now this is just going to give you true and false, because this function is going to start with is. So it always try to deal with the true and false. So here I'm trying to write s dot is subset 3 comma 4 comma 5 comma 6 comma 7 comma 1. And I believe you all will be able to understand if you'll go after the name. Is subset, I believe. So s, yeah. So here 2 and 3, right? S is basically 2 and 3. So I'm just trying to check whether s means whether this particular set is a subset of this particular one. Means, do we have 2 and 3 over here? No, it's a false. Let's suppose if I'm going to add 2 over here, I'm going to add 2 over here. Now it became true that yes, this particular set, this particular set is a subset of this one. So these are the basic functions, guys, which is available inside a set. As you can see, it's not very difficult. It's very easy to implement it. And again, I'm going to repeat almost in every class. I used to repeat this part. You don't have to mug up anything. You don't have to remember anything. No one remembers all of these functions. And we all know that this kind of function exists just with the practice, right? Just with the practice, because we have written those kind of things multiple times. And again, in Python, functions names are given in such a way that you don't have to even remember. Just you will read the function and you will get to know what this function is going to do. And going forward, obviously, we are going to write our own logic. We are going to create our own function. So with that, this is end of this set chapter. See you again in my next Python lecture, guys.